Hey everyone, welcome to The Foundry by Forge College. I am absolutely thrilled to be with you today. We are looking at a really massive milestone in your advanced Solana concepts track. I'm talking about the final capstone build, the Gulfstream efficiency case study. Now, in our last lesson, you drafted your evidence and arguments. And honestly, if you've ever tried to build a capstone project from scratch, you know it's kind of like assembling a high-performance engine while the manual is being written in another language. It takes a ton of hard work and some serious data crunching. But hey, you made it, and today is all about the final assembly. Okay, let's just take a quick step back and look at how you've manufactured all the raw parts over the previous lessons to get us to today. You started way back at step 1, framing the capstone and defining your metrics. Then came data collection, where you captured those transaction attributes. Step 3 was your analysis methods, building out those reproducible Jupyter notebooks. Step 4, you drafted the actual narrative. And well, that brings us right here to step 5, the final capstone build. This is the moment where all those disparate components finally get bolted together into a fully functional machine. And here is our exact blueprint for today. We're going to start with the final assembly line, then build the reproducibility package, learn how to link claims to evidence, run a final stress test, package up your deliverables, and finally, look beyond Gulfstream.
So, Section 1, the final assembly line, organizing your pile of parts.
Think about it like this. Handing an assessor a bunch of raw data and disconnected scripts, it's literally like handing them a cardboard box full of loose gears and saying, hey, here's a clock. Obviously, it doesn't tell time. It just gives them a massive headache. You've got to carefully integrate your clean data, your formatted figures, and your near-final narrative into one single cohesive directory. You're basically putting the gears onto the axles and casing them up properly, so the whole system just ticks perfectly in sync.
Moving right along to Section 2, the reproducibility package, engineering the engine.
Enter the reproducibility script. Usually, this is just a little file called reproduce.sh. This minimal, runnable artifact is exactly what drives the assessor's ability to seamlessly verify your data end-to-end within a single execution environment. Because, let's be real, we have all suffered from that dreaded, well, it works on my machine, syndrome. It's the worst. This script is the ultimate cure for that. It guarantees that your assessor gets the exact same figures and metrics that you did without any of those environment setup nightmares.
So, to pull this off, you're going to follow 3 very specific steps. Step 1, prepare your environment with a super clear requirements.txt file. This locks in your software versions. Step 2, finalize your entry notebook so it runs top to bottom without throwing a single error. And step 3, extract your static figures deterministically. And by that I mean you need to cleanly save your throughput, your latency, and your forwarding event figures straight into a dedicated folder every single time you run it without all those messy code printouts littering the screen. All right, Section 3. Linking claims to evidence, the accountability matrix.
Now, you might be wondering, what's the difference between a persuasive claim and accountable evidence? Well, consider a persuasive claim that just says, Gulfstream is efficient. Sounds great, right? But analytically speaking, it means absolutely nothing on its own. Now, contrast that with accountable evidence. Here, you still state the efficiency, but you follow it up immediately with a parenthetical citation that points directly to a specific notebook cell and a reproducible data slice. Your assessor needs an undeniable trail from your recommendation straight back to an actual line of code. Basically, if you make a claim, you've got to show the digital receipt. I want you to literally burn this rule into your memory. Every empirical claim must reference a numbered figure and the notebook cell that produced it. No exceptions. And I really mean no exceptions. Any of those speculative sentences starting with, I kind of feel like this means, without an evidence trail, just delete them. This capstone is an exercise in ruthless accountability. If your data doesn't explicitly state it, neither should you. Which brings us to Section 4, the final stress test, running the diagnostics.
Okay, let's dive into this acceptance criteria grid. This is your absolute gating condition before you even think about hitting that submit button. For your reproducibility package, validation means actually opening a terminal and running the reproduce.sh script. For claims linked to figures, validation is a rigorous, manual cross-check of your executive summary. And for your recommendation evidence, you validate it by running the specific appendix cell. If you can't confidently check every single one of these boxes, consider this your ultimate pre-flight checklist telling you, hey, you aren't done yet.
So what are the specific checkpoint tasks? Well, first up, a reproducibility run in a fresh clone. This is usually where you experience that mild, cold sweat panic of realizing you forgot a single library dependency. We've all been there. But once you fix it, you verify your generated figures against the images embedded in your final report. Then run a claim traceability audit, do a quick package sanity check, and finally, grab a peer or mentor for a review. Fresh eyes are absolutely crucial. They'll always catch the little inconsistencies that you've just become completely blind to after staring at the screen for hours.
And all of these checks really boil down to one magic number: 3. Your entry notebook must cleanly and flawlessly output exactly 3 specific core figures: your throughput, your latency distributions, and your forwarding event correlations. Oh, and it has to do all of this within a reasonable execution time so your assessor isn't just sitting there waiting all day for your code to compile.
All right, Section 5, packaging your deliverable, shipping the product.
Let's talk about what actually goes into your final submission zip. You're going to need your report.pdf, a reproducibility directory that contains your README, your entry notebook.ipynb, an evidenceindex.csv that maps your claims to your code, and, this is super important, a small sample dataset. I literally cannot stress this enough. Keep it lean. You want to prove that your code works for sure, but if you include gigabytes of raw data, the execution time is going to be massive. Keep it representative, but keep it lightweight.
Finally, Section 6, Beyond Gulfstream, Preparing for Turbine.
You know, this whole time you've been heavily focused on Gulfstream, which deals strictly with forwarding layer behaviors, basically how transactions are pushed to the upcoming leader. By cleanly summarizing your Gulfstream metrics right now, you make it so much easier to contrast them against our next major topic, Turbine. Turbine handles the actual data transfer mechanisms and block propagation. You really need a mathematically sound baseline from Gulfstream to truly understand Turbine's network impact later on.
So I want to leave you with a bit of a provocative question to carry forward. Where do transaction inefficiencies truly originate? Are they happening in the forwarding layer with Gulfstream, or are they happening over in the data transfer layer with Turbine? Having robust, reproducible evidence from this capstone will allow you to answer that question definitively. To explore these layers even further and to continue mastering your Web3 journey, make sure to visit forge.college. You guys have engineered an incredible capstone today. Now go submit it and let's see how fast it can really run. Thanks for joining this explainer and keep building.